Hello everyone. In this video, we'll build a C# Azure Function app and use an HTTP trigger method to connect to a SQL Server database using the Entity Framework Code First approach. We'll retrieve data from a table while leveraging Managed Identity Authentication for a seamless passwordless connection to SQL Server. Previously, I created a video demonstrating this setup using Microsoft Data SQL Client. You can find the link to that in the description. Today, we'll achieve the same goal using Entity Framework Code First instead. Okay, let's dive in. I've created a function app project here. It's an empty project. I just added a HTTP trigger method called getStudents with a empty body. So we're gonna add our code step by step here, and I'll walk you through different setup that we need to do. First of all, we need to install some NuGet packages. So I go to Tools menu and then NuGet Package Manager and Package Manager console. And I use .NET Add Package here to add the first package. It's Microsoft Entity Framework SQL Server. Press Enter. We get an error. We need to navigate to the project directory. So run the command again. Installed successfully. The next one is Microsoft Entity Framework Core Design. And the last one is Microsoft Data SQL Client, because Entity Framework is using this package behind the scene. We just need to add that one as well. Perfect. All NuGet packages installed. Now we go to the local setting JSON file and we add a SQL DB constant here to the configuration file and we put our connection string here. Here you go. In previous video, I explained how we can get the connection string for the passwordless connection in the Azure portal. So feel free to refer to that one if you need to know more details about it. We are done with this step. As I said earlier, we're going to use Entity Framework Code First approach here. Code First approach means that you create your data classes here in the project, and then when you run your project or when you update the database based on the data classes, uh, data tables in the database get created based on what you have here in your data model. That's why it's called code first. You write your code first in the project, and then the database gets created based on the data classes here. So I'm going to add a new folder to the project for our database model classes, and I call it database models. We want to have a student table, so I add a new class called the student here. And we want to have ID, first name, last name, and age. Now we are ready to create a class for our entity framework configuration. So I add a new class and I'm going to call it app_db_context. First of all, this class needs to base db_context class, which is an entity framework built-in class. Then we add this code to its body. So it's got a constructor, which is calling the base method of the entity framework for setting up the connection string and connection to the database. This is the important part here. So for each table that you've got, you use dbset data type, and you use the data model class that we created earlier. So a student class that we've got here, for having a table, we use DB set of that data model. So this means that we want to have a student's table, and its setup is coming from this student class. So this is the most important part. We need to override two different methods here. The first one, again, is getting the connection string and setting up the connection for us. And about the second one, I'll get to that. I'll explain when we can use onModel creating method here. Now we go to our program CS and we add these two lines. The first line is reading the connection string from the config file, and the second line is registering appdb context class with the DI container, and it's passing the connection string to that at the registration time. We save our changes here, then we can go to our getStudent function app method and add our code here. We declare a global variable at the top from appdb context. Also, we add that to our constructor parameters. So it gets injected by dependency injection framework for us. And lastly, we set that global variable here, so we can use it everywhere in our code. Now in the function app body, we can just use that db context method, and we've got the student table, and then you can use toList async to return a list of students from that table, and then we can pass that to the caller of the function app method. That's it. Just build the project. Build was successful. One requirement that we normally have in different projects is seeding the data. It means we want to just populate the table when it gets created with some records. To achieve this one, we go to our appdb context class, and we can use onModel creating method that we created an override for that here. And by adding this piece of code here, you can see your data. So it's adding one record to our students table, and you can add more records if you want to as a part of this collection. So what it does basically, when the table gets created the first time, it adds these records that you've got here in onModel creating override method. Okay, fantastic. So we save our changes. Now we are ready to create our migration script. Migration is a terminology in Entity Framework world, which is taking you from your current database status to a new database status. So for example, if you made some changes in your code and you want to apply those changes to the database tables, you create a migration script, and when you update your database with that migration script, all changes that you made in your data model are applied to your database tables. So to create your migration script, you need to use Package Manager console. So I come here. A few things before running the command here to create our migration. Uh, the first thing that is important is the project needs to be built successfully. So if you've got a build error, this command will fail. So make sure that your project built successfully. The second thing is you need to be in the correct directory, which is in your project directory. So you can check that with the dir command here. It tells you that what is your current directory. And if you are not in your project directory, just use cd change directory command and then the proper directory to navigate to that folder. And lastly, if you run your command, and you get an error that this command is not recognized because the command that we want to run is .NET EF migrations. Uh, and then add keyboard, which is for adding a migration, and this is a name that you give each migration. So this is the first time that we are creating our migrations, so I call it initial create. So next time, for example, if you add a new column to your database, you name it add new column or whatever, uh, and then it creates the migration script. But if it is throwing an error that this command is not recognized, that doesn't exist, you can use this command to install uh, .NET Entity Framework globally on this machine. But I've installed this commandlet earlier. So what I'm going to do is running our migration add command. Let's just run that and see what happens. It builds the project first. Build succeeded, and the command was successful. So if you have a look at the Solution Explorer, you see that a new folder has been added here called migrations. And inside that, you've got migration script that we created. So this is the script basically for creating the students table. And this is the columns that you've got in that table, and this is the seeding command that we added to our code. Okay, awesome. Now that we've got the migration script ready, we need to apply and run this script on a database. You can use a entity framework command here in the package manager console to update the database with the latest migration script, which is called database update command. But in this case, I'm not going to use that for two reasons. The first reason is we are using manage identity connection string, and obviously it doesn't work locally. Second one is we normally want to do that as a part of our deployment process. So we want that migration automated in the deployment pipeline. So to achieve that, I'm going to just add a piece of code to our program CS file. Come here and add this code. What it does basically, it runs all the migration scripts that haven't been run before on the database, and it makes sure that there is no pending migration on the database. So after each deployment, because your app service is stopped and restarted again, this method in the program CS is called again, and it applies all the migration on your database. One thing that might be worth doing that is adding a flag in your configuration file, a Boolean flag, and set it to true or false. And based on that flag in the program CS, put this block inside a if block based on that configuration setting. So if it is true, you apply the migration. If it is false, you skip the migration stuff. Alrighty, perfect. We've done with this step as well. So I just save and build the project one more time. Now we are ready to deploy our function app to Azure. So I explained these steps in the previous video. I'm going to just skip these steps here. And after deployment, I'll show you what's happened on the Azure side. Alrighty, I deployed the function app to Azure, and you can see the function app created here, and we've got the app service plan for that as well. If I go to the function app, you see that get a students method is here. Also, if I go to environment variables, I've added a environment variable here, SQL DB, and we have our connection string to the database here. Also, I've created a manage identity for the function app, and I also added that in the SQL Server configuration. So I've done this stuff in the previous video. I'm not going to repeat them again here. If you need more details, please refer to the previous video. Also here, if you have a look at our database, currently we don't have a students table here. If I run the function app there in the first run, it's going to create the students table, and it's going to populate that with one record that we've got in our seeding, and then we can just see that in this area. I come back to the function app methods and go to get a students and click on test run and click on run. Here you go. We have a 200 response code, and as you can see, the content of the response body is the record that we added in our seeding. If I go to the SQL Server and refresh there, we should be able to see that tables created there as well. So we refresh here and open the table, and here you go. The students table is here, and this EF migration history table has been created by Entity Framework to store your migration history in it. If I select the rows from that table, you see that Tom Doe is in this table. Also, if we go back here to the function app, you can get the function app URL and put it in a browser. And if I press enter, you see that we've got the same result here in the browser as well. Just bear in mind, as I explained in the previous video, we are using anonymous authentication level for function app, which is not a good idea for a production product. But for ease of use, here we are using anonymous access level. You can find this video source code in my GitHub repository. It's OZAP Builder YouTube channel samples. And you can find this video's code in the function app Azure SQL Entity Framework demo folder. And there is a sample.cs file, and you can find the code there. Okay, we managed to access Azure SQL Database using Entity Framework code first approach. And also for authentication, we used Manage Identity, which is a passwordless authentication. That's pretty much it. Thanks for watching the video. I'll see you soon. Bye.